Moving forward, if we continue now with chapter 3, exercise 3.4, no, elementary transformations. We will be focusing only on row transformations only here. Okay, find the inverse of the matrices if it exists. Now one request is, please complete the video, please go to the entire length of the video. After that only you can see whether you have liked the video or not. Using elementary transformations, find the inverse of each of the matrices if it exists. Now you have to remember one note here, that is, in case after applying, if it exists, no, because the question is that. So in case after applying one or more elementary row or column transformations, like maybe one entire row or column completely turns to be 0, then if we obtain all zeros in one or more rows of a matrix on the left hand side, then inverse of A does not exist, because here this is by elementary transformations only. Okay, so by determinant method, of course, that was quite easy for us, no? Because all we had to do was get its determinant. If it is not equal to 0, then yes, it will have a unique solution, and then it'll have a unique solution also, and then we can find out its inverse also. But for elementary transformations, the only way to find out is when applying row operations and all. If we get one row completely 0, then yes, then in that case only we say that okay, it does not exist. Okay, for example, like after applying you get 1 2 0 0, something like this. After applying the rows elementary row operations, in that case we will stop there and state that A inverse does not exist. Let's continue here. Let's see. So first step, what do we do? Step 1, we know that A is equal to I into A. So we will write down the matrices 2 by 2 A. Now after that, what did I tell you before? That is, we will focus on one row or one column only. Okay, and then try to convert that into, because this one will be trying to convert it into an elementary identity matrix. No, so maybe we can focus on this row. That means I'll try to get 1 0. So see, R1 R2 I can write it as R2 minus 2 times of R1. That means R1 I will leave as it is. So R2, if I change, so that will be 2 times, R2, 2 minus 2 times of R1, 2 minus 2, 0. Here 3 minus 2 times of minus 1, 3 plus 2, 5. And here 0 minus 2 times of 1, minus 2. Here 1 minus 2 times of 0, that will be 1. Okay, one step is applied. Next step, it's quite simple. Next step is already understood, because remember, we just have to try to get one row or one column as 0 1 or 1 0, no, or 0 1, any one of it. So now here, if I just divide by 5, that is R2, if we simply divide by 5, there we have it, minus 1 0 1, 1 0 minus 2 by 5, 1 by 5. Now all I have to do is now almost there, just convert this to 0. That I can do by adding these two rows. That means R1, if I just add R1 plus R2, so that will be 1 plus 0 1 minus 1 plus 1 0. So the remaining terms will remain the same. So this is already complete. So now we have to just check what we have here. So R1 plus R2, 1 plus minus 2 by 5, 1 minus 2 by 5, so 5 minus 2 by 5, 3 by 5, 0 plus 1 by 5, of course 1 by 5. So that's in the form of AI equal to B into A, which implies B is equal to 3 by 5, 1 by 5, minus 2 by 5, 1 by 5, which will be equal to none other than the inverse of the given matrix. So we have 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. So this will be the inverse of the given matrix. So we can of course check also. This is not needed, okay, but just to verify, A into A inverse. Let's try to find out. A, 1 minus 1 2 3 into A inverse, 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. So let's try to multiply first row, first column. So 3 by 5 plus 2 by 5. 1 by 5 minus 1 by 5. 2 3s are 6 by 5 minus 6 by 5. 2 by 5 minus 3 by plus, no, 3 into, yes, plus 3 by 5. So what do we have here? 5 by 5, 0, 0, 5 by 5. So it should give us the identity matrix, which is correctly true. So it's as simple as that, but of course as the matrix gets bigger, your problem will slightly get more complicated. So you need to keep your calm. Practice a lot, of course, and just focus on one particular row at a time, one column at a time, one row at a time. Okay, so then in that case it will be very easy for you. Don't try to manage 4 or 5 rows at one time. 2 3 rows at one time. Just focus on one. So in the next videos we'll try to solve more questions on this, and we will see how we can proceed. But we can continue with maybe one more question. There's no harm in doing for one more question. That is, maybe we can try question number 2 also. The matrix A is given 2 1. So since time is still left, let us just try to do this quickly. 1 0 0 1. So this is a simpler one. So what can we apply here? Remember, get one row or one column 0. So maybe this will be easy to get, no, for me 0. So R1, I'll apply R1 minus R2. Simple as that. So 2 minus 1, 1, 1 minus 1, 0, 1, 1. So 1 minus 0, 1, 0 minus 1, minus 1, 0, 1. Same operation here also will be applied. So this is already done. This is a very simple question, of course, you see. So now I'll just focus on this one, converting to 0. So simply 1. So R2, I can just write R2 minus R1. So R1 I'll not change. So 1 minus 1, 0, 1 minus 0, 1. 0 minus 1, minus 1, 1 minus 1, 1 plus 1, 2. So this was a very simple question. So that's like I equal to B into A. So this implies B is equal to 1 minus 1 minus 1, 2. That is nothing but the inverse of the given matrix. So likewise, it's not very difficult. Do practice. Next video we will try to solve we'll try to find out the inverse of a 3 by 3 matrix, which will be more interesting. Thank you. Stay safe, stay at home, but don't let the holidays or the lockdown that we say come in the way of your studies. Please prepare well. So thank you from the team of Teach Nagaland.